Okay, so number 31, or problem like number 31 on 1.4. So what is that question asking? That question is saying, evaluate the function at the specified value and simplify. And it's some kind of composite function. So I'm going to talk about number 32 instead because it's similar. So it is written like this. So you have however many components, which I talked about in class. They're like strips. And over here it tells you where each strip is valid. So this means use this function when this is true. And so if you look at the way this is split up, okay, x is equal to -2 is here, x is equal to 2 is here. So the first strip is everything to the left of that dotted line. The next strip is right here between -2 and 2, and then the last strip is everything to the right of x equals 2. And so if you were to plot each of these little functions, well, this one is pretty easy. The one in the middle looks like that. And then if you had x squared plus 1, it would look something like that. So it looks kind of like that. So the rest of this function is missing. And then 4 minus 5x would look like this. So it would be something like that. I'm going to erase these because they're kind of confusing now. So this is what this function basically looks like. And you may ask, well, how do I know how to fill in the barbells? So every time there's a split, there's going to be two circles, one of which is filled in and one of which is not filled in. And you have to look back here to tell which is which. So for example, if I had not put the equal sign here, instead I put the equal sign here, then it would switch. Then on the left side, this would be empty. On the right side, it would be filled in. So remember, if it looks like this, you're going to have a filled in circle. If it looks like this, you're going to have an empty circle, because it means it's the equality condition is not met at that point. Like you don't put the limit, you don't grab the limit case. All right. So what do the questions say? It says f of -3. So -3 is going to be over here to the left of -2. So you're going to use this first function up here. So you're going to use 4 minus 5x. And so that's going to be 4 plus 15, which is 19. Okay. F of 4, you're going to use this function here, x squared plus 1. So it's actually going to be 17. And f of -1 is just 0 because it's just inside here. So those are the values for that question. Of course, number 31 is slightly different. Number 31 only breaks up into two regions. It breaks up into the region to the left of the y-axis and to the right of the y-axis. And the barbell is attached to the right-hand side. So your 2x plus 2 function is the one that gets the filled-in barbell, and the 2x plus 1 gets the empty hole. So that should get you started on number 31. Okay. Okay, now what about 41 through 43? What are those questions asking? It says, find all real values such that f of x equals 0. I think we did actually talk about these in class, and that's when I handed out my website. You can practice factoring. You're going to need factoring pretty soon. I'm going to do actually number 44 because it looks like fun. So if I have f of x equals x cubed minus x squared minus 4x plus 4, I actually have a more advanced technique that I wanted to show you, which is you have to sometimes see that there's a symmetry between these two pieces, and you have to factor out the best you can This particular one is a little tricky because you have to notice that the sequence of signs is plus, minus, minus, plus, which means that you have to factor out a negative something in the second half of the problem. But the goal is that you want these two guys to be the same thing. So now what you're going to do is factor out the x squared comes down here, the minus 4 goes over here, and then you group the negative. Sorry, I had to sneeze. So let me explain to you what this is. Let me at least try to prove to you that this is correct by going backwards. All right, if I wanted to multiply, I can use foiling to verify that this answer is correct. First, outer, inner, last. Okay? FOIL is an acronym for distributively multiplying, which means first, outer, inner, last. Those four combinations need to be multiplied, and that will tell you what the final product is. Okay? Again, this is a more complicated example, and this is why I picked it. I thought that you should see it. I'll be honest, we did not do this when I was in high school, and I had to learn it by teaching it. So, but it's fun. Okay. So x is equal to 2, or x is equal to negative 2, or x equals to 1. Right. I'm not planning on giving you a question like this on the exam, but I do think this kind of thing would be fair game for homework or a practice exam or something like that. So I want you to be exposed to this technique. I want you to see it. If you haven't mastered it, that's okay. But I will expect that you master the ability to do the other kind of factoring, the one that is the typical unfoiling that you're used to. So things that look like, you know, your x squared minus 8x plus 15, you should be able to handle that type of question. So you work on that, okay? I think that's all you need for that type of question. I mean, you do know, we talked about this in class too. If you have something like this, it can factor like this. So that's a hint for your homework if you're stuck on that question. And you know, if you have a perfect square minus a perfect square, it always splits up into sum and difference. If you guys are having trouble with any of this, let me know and we'll go over it in more detail in class. These videos are meant to be a little freshen up reminder, because I think you've seen these things before, but if I'm wrong, then we will take more time and cover it in more depth in class. Okay, number 48 is very similar to the style of 41 through 43. Again, we did already cover these ones in class, but this again is just a little refresher. We have something, I'll do number 47 instead. You have something on the left-hand side, which is your f of x, is equal to something on the right side, which is your g of x. Okay, and so we want to see when this is true. And this is your baseline that you have to go back to. If we do any kind of weird stuff that introduces possible false roots, this is the thing we're going to test against. This is our original setup, because this is not coming from a physical problem. We don't have something more authoritative to check against. So we're going to go ahead and put the minus 2x squared on the other side by adding 2x squared to each side. I'm going to divide both sides by x squared, and you see x is equal to 0 is an answer, so we have to keep track of it. So we're getting into this divided by 0 issue. Okay, so x is equal to 0, x is plus and minus 2. Then you look at the original question and you say x equals 0 works, x equals plus and minus 2, that works as well. So we're good. So all three answers are valid. Okay, you do something very similar in 48, but if I recall, we ended up, it actually required some kind of different technique. So let's just talk about that one. We said square root of x minus 4 is 2 minus x. And we talk about how we can FOIL that. would rather unfoil that. Okay, so we talked about the fact that your eye should see this as something squared plus something minus 6. That something happens to be square root of x. So it makes it kind of weird. Right? And then you can say, well, square root of x minus 2 is 0, square root of x is equal to 2, and then square both sides. Alright, so the question is, does this work back in the original question? And square root of 4 is 2, 2 minus 4 is negative 2, and 2 minus 7. This is okay. This one works in the original situation. So that's fine. But then we have the other root, the square root of x plus 3 is equal to 0. Square both sides, and then does this work in the original? So we have 3 minus 4, is that equal to 2 minus 9? 2 minus 9 is negative 7. No, this is completely bogus. So this one fails in the original environment, okay? And so that's, you have to write that up in a cleaner way than what I just did. But that tells you how to explain that answer. Okay. Moving right along to 65. Path of a ball I did talk about in class, and that is, this question indicates that there's some kind of upside down parabola. And you have a little kid over here with a glove up in the air, and the total tip of the glove is at 5 feet. And the kid is standing over here 30 feet away from the other kid who is throwing the ball. Okay, so this is the physical setup. This is at 0 feet, and this is at 30 feet. Okay, and the question is, will the ball fly over the other kid's head, or the other kid catch it, or what's going on? So all you have to do is plug the 30 in for x and see what y comes out. That's really all you have to do. The hard part of the problem is understanding the question. So again, just plug the 30 in here and see what happens. And then just say, is this y greater than 5 feet, equal to 5 feet, or less than 5 feet? And then you'll have your answer to your question. All right. And what about number 71? This one we didn't talk about. Okay, so this is the first question we did not get to in class. So number 71 didn't do in class, because I think this is the first one we ran out of time for, this type of problem. Cost, revenue, and profit. So if you're going into Math 211, which I don't think you are, but if you were to go into Math 211 after this, which you'd be allowed to, that's applied calculus. And these kind of questions come up a lot there. So this kind of question also comes up a lot in Math 160, which is the analogous pre-calculus class to the one that you're in. But it's the pre-calculus that's intended for people going into applied calculus. But they have a lot of really cool economics applications, so it's fun to do them in this class as well. Okay, a company produces a product for which the variable cost is $12.30 per unit. So this is variable cost. I'll tell you what that is in a second. And there's some kind of fixed cost, $98,000 fixed cost. And the product sells $17.98 is the price. They're hitting you with everything. X is the number of units, both produced and sold, so that's great. Okay, so what this model is saying is you're fitting a line. The line, this right here is the same as your y-intercept, and this is equivalent to your slope. So the variable cost is the cost per unit, and the fixed cost is the cost associated with just setting up the business in the first place. So these all have to do with the cost to produce, and then this tells you the revenue is the price you get per item. Will give you the revenue, and then the profit is going to be your revenue. So profit is equal to revenue minus cost. So it's a really, really simple model. And so what they want you to do is find the total cost for the business. Actually, they tell you what I just told you. But part A says find the total cost function. So all you have to do is say it's 98,000 plus 12.3 times x. You can put the 0 in there, I don't care. Okay, so that's the total cost. And the total revenue, they want you to just think about this. The total revenue is $17.98 per unit, and there's x units. So it's very easy. And then profit is equal to, I'll let you do the last step, is revenue minus cost. Don't forget there's going to be a negative out front of this 98,000. This is going to be negative. So it's 1798 minus 12.3. And that makes sense, right? So forget about fixed costs for the minute. The amount of money you're going to make on each unit is the price you're selling for minus the price you paid to produce it. So it's like 18 minus 12, right? You're going to be making about $6 for each unit you sell. And first you got to make up your fixed costs, so you're going to start off in the hole. Profit is going to start off negative, and then there's going to be a point at which you just pay off your startup costs, and then you're going to finally be in the black. So that's all that question is asking. Okay?